So today we will talk about 3D Mesh and its components and try to understand how 3D graphics works and how to create your own 3D models, how to visualize anything, basically anything. So how to display a three-dimensional scene on a flat screen. This may sound as an interesting question, but you just only need to build a projection. And the idea is similar to the way a camera works, usual photo camera, and how to take a flat photo of a three-dimensional world. Well, when you take a camera, you basically do what? First thing, you choose what to shoot. So find or arrange the objects you need. For instance, if you want to make a picture of a landscape, so you need just to pick a good landscape. If you want to make a portrait of someone, so you need to ask those people to stand somewhere in the place you want. And the second part is to choose where to shoot from. Choose lighting, camera angle, and zoom, of course. So it depends. Of course, you can stand more to the left or more to the right, and depending on this, you will see another background image. So in 3D graphics, the idea is similar. So the first thing is to set and arrange the subjects for shooting. The second one is set the lighting and angle. So is it different from 2D graphics? Well, let's take a closer look at the first stage. Set and arrange objects for shooting. So how to define a 3D object? Well, this may sound an interesting question, but actually, if you understand the basic components, then it's very simple. So you need just to specify its basic components. And what are they? Or which ones? It's very simple. So any 3D object in 3D graphics consists of three structural elements: vertices, edges, and faces. And you can see them on this image. So it's denoted by an arrow. So the vertex is just a point in 3D space. Edge is just a line connecting two points. And face is just a polygon. So where vertices are points in 3D space. And they are defined by the coordinates x, y, and z, or z. So edges are lines in 3D space, and they are defined by the start and end coordinates. They are vertices, yes? The start and the end point are vertices, and therefore they are also defined by x, y, and z coordinates. So edges are polygons in 3D space. They're defined by the coordinates of their vertices. I'm sorry, there is a mistake. There should be faces. Faces are polygons. And now, if you take it all together, so a set of vertices, edges, faces, they form a 3D object. And this is all called a mesh. The vertices are usually set in counterclockwise order. And for example, if you have any face, any polygon, and you want to just say this is vertex number 1, number 2, 3, and 4, or how many you like, you need to specify them in counterclockwise order. This is important so that any rendering software understands which side of the polygon is external and which one will reflect the light. It is also common to further divide all faces into triangles, or there is a verb to triangulate. For example, a cube has faces that are squares, but they are usually divided into two triangles. So just like this, you can see there is a cube, we have a top face, and it's also divided by a diagonal line into two triangles. And you need to specify the points in the counterclockwise order. So we need to specify V1, V2, and then V3, not V1, V3, V2. so that the rendering software understands so that this is the upper part, the external part, and it will reflect light and any other light sources. Since vertices are always connected by edges, and edges in turn belong to faces, it is enough to list all the faces to define any 3D object. That is, the coordinates of the vertices of each face. Of course, it should be counterclockwise. So if you look at this picture, well, you can see many different shapes. So the simplest ones are the cube and the pyramid. And well, if you look at the cube, you just need to specify all faces, yeah, and in counterclockwise order, the vertices of each face. Same goes for the pyramid. Same goes for cone and for the sphere and for other objects. The cylinder. So let's take a look at this example. So here's the cube, and it has been divided into triangles, each face, except from the upper face, because I haven't found the picture where all faces are triangulated. So let's imagine that the upper face, also the top face, it also is divided by a diagonal line into two triangles. So how do we specify this cube to record it, yes, for the system, so that it can be rendered on the screen as a 3D object? How do we specify its mesh? So we need to just enumerate all points and specify the faces one by one. So let's, okay, the first one will be the triangle 0, 5, 4. It's the front face. And also the front face has another triangle, 0, 1, 5. So now we have two triangles to specify the front face. Now let's go to the right face. So the first triangle is 5, 1, 2 and 5, 2, 6. Okay, now let's go to the top face. It's 7, 4, 5. Maybe someone wants to take a guess. What's the second triangle here in the top face? It's counterclockwise. Okay, it's 7, 5, 6. And now let's go to the left face. And of course, you might think that it should be 3, 4, 7. And it is 3, 4, 7. Because if you say 3, 7, 4, it's incorrect. If you look at this cube, you need to imagine, to turn on your spatial imagination, and to imagine that you look at this cube from another side, another point of view. And if you look at it from another point of view, another side, so it's counterclockwise, it will be 3, 4, 7. So not 3, 7, 4. And the same goes for the another triangle. It's 3, 0, 4. So now let's go to the bottom face. It's 1, 0, 3. Again, we see that it might seem it should be 1, 3, 0, but we look at it from the inside. Yes, we need to look at it from the outside of the cube. Imagine that you look at it from another side. So counterclockwise, it should be 1, 0, 3. And the other one is 1, 3, 2. And the last one is the rear one. It's 3, 7, 6 and 3, 6, 2. Again, imagine that you're looking at it from the outside, not from the inside. So how to store information about a 3D object in a 3D file? So many file formats for storing 3D objects are text files that contain the coordinates of each vertices of each face of the object. I know it may sound a little bit complicated, but in fact, you just need to enumerate all the points, and that's it. So face number 1, 1, 2, 3 points. Face number 2, 1, 2, 3 points. That's it. So for example, there are the following file formats for storing 3D meshes. It's the most popular are STL, OBJ, FBX, DAE, which is also known as Collada. Some file formats store the same coordinates, but in binary form, not in textual form. For example, 3ds, STL, OBJ, and FBX. As you can see, both STL, OBJ, and FBX can store data in text and binary form. So why would they make two different forms to store the same file format? The binary format is actually a little bit works a little bit faster because well, the access is performed to bytes, the offsets and bytes, and the read time is a little bit faster than the text file, because text file might have spaces, tabs, many characters that you just need to skip. So the read time may be a little bit longer. So the most common 3D graphics formats are, so text is DIA, Collada, only binary is 3ds, which is used in 3D Studio Max, and both can be STL, OBJ, and FBX. So usually software which renders 3D graphics can understand both text and binary formats for these types of files. So what software do you need to create 3D graphics? Of course, 2D graphics software is not suitable for this. So if you take, for instance, Paint, Windows Paint, you cannot create 3D graphics. You might create only 2D graphics or something which is a projection, or flat projection. It's like drawing on a piece of paper. Also, you can take Photoshop, for example. The new versions of Photoshop, they have a special feature. You can add a layer which contains 3D graphics. And actually, you can put a 3D object there on a 3D layer. You can even rotate it in 3D, look at it at different angles. But if you try to export this image as JPG or PNG, of course, the projection will be made. It will be just like a photo, a picture. And once you export it, you cannot rotate the object. It's like a photo. You can, if you imagine your picture, you're making a picture of some object, and once you have it in your smartphone, can you rotate the object, see what's behind it? Of course not. So the same goes for Photoshop. Yes, it does. It has a feature to import 3D objects, but only if you save it as a temporary Photoshop document, PSD file. But once you export it in the image file, the 3D features are lost, and you only have a flat projection. But as for 3D graphics, there is specialized software for this. Of course, you might all have heard about Autodesk 3ds Max. Of course, since an enterprise product, you have to pay for it, but it's very powerful. It has been there since like 1990s, I guess. I think it's one of the oldest. It's not, but it's not one of the worst, of course. So this product is actually good because of its features, its experience. So everything that you can think of is already implemented in 3ds Max. So it is used for many things like creating special effects in video games, movies, and many other stuff, cartoons, animations. So it's a very powerful tool. Of course, it takes some money, and it takes some computer resources, many gigabytes. But if you use it, then you really know what you're doing. Also, there is an open source alternative, Blender. It's very lightweight, and it can be run on Linux as well, Windows, Linux, Mac OS. And so the most important feature, of course, it's cross-platform. It's free and open source, and you can expand it by using different plugins. You can write Python scripts. It even to create simple video games, of course, animations. So there were even some cartoons created in Blender. And of course, it's very lightweight. You don't need many gigabytes of your hard drive space. So I think even pretty average laptop can handle Blender. So if you are new to 3D graphics and want to take a try and want to create your first some first 3D object, Blender is good to go for you. Also, there is another product from Autodesk company. It's called Maya. It's not the same as 3ds Max, but it's pretty similar in the way that this Maya is only used for animating characters. So it was like a fork of 3ds Max, but a very specific fork for rigging the character. Rigging means putting the places, taking a model and animating it, uh, just setting the points where the joints should be, like arms, legs, head, neck, and so on. So what can bend, what can move, and what cannot move. Of course, you can also create face for your character, facial expressions, hair, clothes, and so on. So it's widely used for creating cartoons. Also, there is another product called Maxon Cinema 4D. Probably it's less famous than Autodesk 3ds Max or Blender, but it's also worth taking a looking of, because well, it's pretty simple to start with, but in the same time it's pretty powerful. So also worth mentioning. Also, there is another product from Autodesk. It's called AutoCAD. It's a very specific software. It's used primarily for engineering some drawings. For example, if you're an architecture and you need to create a very precise drawing blueprint of the house, of some detail for the car, vehicle, or anything else that needs pretty specific and very precise measurements, uh, AutoCAD is very good for this. Also, if you want to just to relax and have a good time and have fun and just a very easy piece of software, then SketchUp is also worth looking at, because uh, it may seem that this graphics seems like cartoonish, childish, but actually it's not. If you take a look at this screenshot, it was made in SketchUp. So the idea is that in order not to uh, okay, to increase the performance of your video adapter GPU, so the graphics is intentionally made cartoonish, like very simple graphics, so that you can focus on the modeling part of the focusing and setting an object, their measurement, size, locations, and so on. And once you're done, once you're ready, once you're satisfied with your plan, usually it's usually used for planning, designing interiors. So once your interior is ready, you can run a render process. The rendering process can take up to many hours. So my friend was working professionally with SketchUp, uh, making interior designs for clients. So usually, an average design would like this, with shadows, lightings, water reflections, and so on. It can render up to 6 or 7 hours, if you depending on the number of objects you have, number of mirrors, water, windows, light sources of light, and so on. And here you can see the comparison of different 3D rendering software and what types of 3D formats they support. So, for example, you can see that SketchUp, well, it doesn't support STL files, but it supports OBJ for export and FBX for export. It supports Collada, both import and export, 3ds both, and VRML. So in this case, probably Rhino seems one of the best. Cinema 4D is also pretty good. And there is also Unity. Unity is not actually rendering software, it's a game engine, but it's given here like for comparison. So of course, you can, if you're making a video game using Unity engine, you can import 3D models, OBJ, FBX, Collada, and 3ds, which is a pretty good set of supported file formats. Of course, you cannot export because Unity is not an editing software. It just can be used for importing assets, 3D models, components, just to set game seed and to proceed with the code. And you can use all the other ones for actually making mesh. You can use, for example, Blender. You can just create a cube and then do with that cube whatever you want. So any object can be built like in real life by sculpting, by modifying, by cutting something, by drilling holes, by modifying this the way whatever you want. You can do whatever you want with it. You just need to specify, yeah, the vertices, the edges, and the faces, of course. And there you go. So of course you don't need to write the coordinates manually. You just take 3D Max or Blender, and you just try to like, there is a sculpting mode. You can like be a sculptor in 3D to paint textures, colors, set materials for that mesh so that your object looks very realistic. And so, of course, you also need to take a good look at the number of polygons. So the more polygons your object has, so the longer it will take for the GPU to render it. And if you're making an animation, like a video game or a cartoon, then you can imagine 24 frames per second or more, 30, 60 frames per second. And so if there are many polygons and many objects on your scene, of course, it will take a long time to render it. But actually, if you use not many polygons, your object might seem a little bit not real, not realistic. So you need to find the perfect balance between the number of polygons and the rendering time. So, of course, there are no rules, there are no laws in 3D graphics. You just need to be like be a good artist. Even if you're not a good artist, you just need to have a sense, like actually what actually looks good, and who are you making this for? Who is your target audience? So if it's a video game and you're uh, targeting for like students or kids, um, maybe it can be cartoonish. If you're looking for serious gamers, you need to uh, try create high poly models. You can find many models online. You can download them and modify. Many of models are paid. So if it's a really great model, so of course the author wants some money for it. You can also create your models. You can publish them. You can earn money on that. So, and I think pretty good money. So, and you can make a portfolio if you like this area. You can always find a job as a 3D modeler. So thank you for attention.